Chapter 6.2, the natural base e. So far you have in your study of mathematics, you have worked with special numbers such as pi and I. Another special number is called the natural base and it's denoted by e. The natural base e is irrational, so you cannot find its exact value. Exploration we are going to do for natural base is you need to consider this expression 1 plus 1 over x to the power x. So whatever goes here, it's the same on the top. As x increases, the value of this expression approaches the value of e. We are going to complete this table right here. 10 to the power 1 means just 10. 10 to the power 2 is 100. 10 to the power 3 means 1000. 10 to the power 4, 10,000, and so on. Here we are going to apply this method and we are going to put x as 10. So we are going to have here is 1 plus 1 over 10 to the power x. So what we're going to get here is 1.1 to the power 10, and that's going to give us 2.593. Next we are going to put 100 for x, so you're going to get here is 1 over 100 to the power 100, and that when you solve you're going to get here is 1 plus 0.1 to the power 100, and your answer is 2.70481. Similarly, when you put 1000 for x, you're going to get your answer as 2.71692. So the rest of the answers for 10 to the power 4, you get this answer. For 10 to the power 5, you get this answer, and 10 to the power 6 is this. You're going to use the calculator and find these answers. The natural base is used in a variety of real-life applications. One application is continuously compounded interest. As the frequency of compounding increases, the formula for compound interest is A equals P 1 plus R over T to the power NT. Approximate the formula for continuous compounding. A P times e to the power RT, because now this part of this one is called e. So you got ERT. This can be done with the calculator. Let P is 1000, R equals 6%, and T is 10. Now we are going to solve this with this formula. With this formula, we're going to solve the compound interest when it's counted quarterly, when n equals 4. What should be the amount? Okay, so again, for the quarter, you're going to use n as 4 and 0.06 divided by 4, and on the top you're going to get 4 times 10. You're going to solve this whole thing in one shot in the calculator, but I can write this for you. You first solve the bracket and the power inside, and then you multiply it by 1000. So the answer is 1814.02. Next is when n is 12. When n is 12, you're going to use 0.06 divided by 12, and on the top you have 12 times 10. You're going to solve the whole thing into the calculator. First you're going to solve the bracket and then take a power and then multiply it by 1000, and your answer, final answer, is going to be 1819.40. Next we're going to use n as 52. So you're going to have 1 plus 0.06 divided by 4 divided by 52, and on the top is 52 times 10. Solve the bracket first, take the power and then multiply by 1000. Your answer is 18, 21 and 49 cent. A equals 1000, N is 365. So 0.06 divided by 365, 365 times 10. Your answer is going to be 1822.12. The last one is a continuous, and this is the formula A, P times e to the power RT. You would see that E in your calculator. So type this first and then press E and then multiply by 1000. Your answer is going to be 1822.12. Continuously compounded interest. When interest is compounded continuously, the amount A in an account after T years is given by the formula A equals P e to the power RT, where P is the principal and R is the annual interest rate expressed as the decimal. So now this one is the formula you're going to use every time you're counting the interest continuous throughout the year. It's not by daily or weekly or quarterly. It's counted continuously throughout the year.